Hello everyone, and welcome back to the 3D Mechanical Design channel. I'm a mechanical engineer with over 20 years of hands-on experience working with SolidWorks. In today's video, we'll explore how to use the Fill Pattern tool. This powerful feature combines the functions of both linear and circular patterns, allowing you to efficiently create complex layouts from a single seed cut. As our first example, we'll create a pattern on a sheet using hexagonal cells. To activate Fill Pattern tool, you can do either of the following. From the Linear Pattern menu, click Fill Pattern or go to Insert, Pattern Mirror, Fill Pattern. Once the Property Manager opens, specify the area to fill in the Fill Boundary field and select the surface of your part. Next, under Create Seed Cut, select Hexagon. For this demonstration, we'll define our seed cut with 6 sides, each 5 mm in size. In the Vertex field, you can choose the pattern's starting point. If you leave it blank, SolidWorks will automatically center the pattern. You can also rotate each element by a defined angle if needed. Use 90 degrees. You'll also find other shape options such as circle, square, and diamond. Under Pattern Layout, let's set Instance Spacing 10 mm. Stagger Angle 60 degrees. In the Margins field, define how far the cutouts sit from the edge. You can even use negative values if necessary. If no edge is specified, SolidWorks typically determines a direction automatically, which you can reverse by clicking Reverse Direction. After entering all parameters, you'll see the calculated number of cutouts displayed in this field. Click Validate Count, and SolidWorks generates a precise grid and numbers of hexagonal cells. Click OK, and we've got our perforated plate. Now, let's modify a few parameters to see how the pattern updates. You can also use the Instances to Skip option to remove selected cutouts from the layout. Once you're done adjusting, click OK again, and you'll see the updated design instantly. Now, where can we use this type of pattern? Let's take it a step further. We'll bend the sheet into a cylinder using the Flex tool. As you can see, the result could easily serve as a decorative vase or even a functional filter. To finish it off, let's add some edging around the perimeter. The final form resembles a beautifully detailed fence segment, almost like a decorative panel. If you found this tutorial helpful, please like the video, share your feedback in the comments, and consider supporting the channel for more engineering content. The complete 3D model is available for download. The link is in the video description. Thanks for watching. In the next video, we'll look at some more features of the fill boundary tool. See you in the next video.